Circles also have unique characteristics. Circles have a total of 360 degrees. Their area can be found by the formula A equals pi times the radius squared. Many times, circles are defined by their diameter. In this case, the area is equal to pi times the diameter squared divided by 4. In manufacturing, it's important to know how changes to the diameter affect the area of a circle. If the diameter of the circle is doubled, what will that do to the area? By substituting 2 times d in for the diameter, we can see that when the diameter of a circle is doubled, its area is quadrupled. This is because both the old diameter and its multiplier 2 are being squared. Similarly, if we triple the diameter, the multiplier becomes 3 and the new area will be 9 times larger. When we double the diameter, the multiplier is 2. When we triple the diameter, the multiplier is 3. In general, an increase in the diameter of a circle will result in an increase in the area equivalent to the multiplier squared. A painter was hired to paint the cement floor in a basement. The basement is rectangular in shape, but has several large circular posts and a large triangular built-in cabinet. He needs to determine the total square footage he's required to paint so that he can purchase materials. First, let's determine a general formula for the area the painter must paint. The paint area is equal to the total area of the rectangular basement minus the triangular built-in, and minus the posts, there are 4. Substituting the formula for the area of a rectangle, triangle, and circle gives a final equation of length times width minus 1/2 base times height minus 4 times pi times diameter squared divided by 4. The painter measures the appropriate distances, and now we can substitute the correct numbers and solve for the area.